Here's what separates code that's easy to test and extend from code that fights you at every turn. How it wires its dependencies together. Go has no dependency injection framework, no annotation-based middleware system, no plugin runtime baked into the language. And that's deliberate. 3 patterns cover almost everything you need, built entirely from interfaces and functions you already know. This episode covers dependency injection, middleware chains, and plugin architecture, the patterns that let simple Go pieces compose into real application structure. Dependency injection means a component receives its dependencies from the outside instead of constructing them itself. In Go, that's an interface plus a constructor function, nothing more exotic than that. Define an interface for what you need, a logger with a log method. Write a concrete implementation, console logger. Then write a service struct that holds a logger field, and a new service constructor that takes a logger and stores it. The service depends on the interface, never on console logger directly. It doesn't know or care which implementation it received. This buys you 4 things: testability because you can swap in a mock, flexibility because you can swap implementations without touching the service's code, decoupling because the service has 0 knowledge of concrete types, and maintainability because the constructor signature tells you exactly what the service needs. This is where dependency injection pays for itself immediately. Write a mock logger that implements the same logger interface but records every call instead of printing it. Pass the mock into new service exactly as you'd pass the real one. The constructor doesn't change, the service doesn't change. Now the test calls service.doWork and asserts against mocklogger.messages. No real I/O, no console output, no external dependency the test needs to set up or tear down. The test is fast, isolated, and deterministic, and none of that required a mocking framework. It's the same interface satisfied twice. The pattern generalizes to anything a service depends on: a database, an HTTP client, a clock. If it's an interface, you can fake it in a test. Real services usually need more than one collaborator. The pattern doesn't change. Add more interface-typed fields and more constructor parameters. A service might hold a database, a cache, and a logger, all injected through new service, DB, cache, logger. The value here is that every dependency is visible in one place. The constructor signature. There's no hidden global state, no service locator you have to trace through the codebase to understand what a type actually needs. Read the constructor and you've read the dependency graph. This is Go's answer to what other languages solve with DI containers and reflection-based auto-wiring. For the vast majority of applications, explicit constructor injection scales just fine without a framework. Middleware is code that runs before and after a handler, logging, authentication, rate limiting, without the handler itself knowing any of that is happening. In Go, a middleware has a simple shape, a function that takes an HTTP handler and returns a new HTTP handler. Logging middleware takes next and returns a handler func that records the start time, logs the incoming request, calls next.serveHTTP to run whatever comes after it, then logs the duration once that call returns. Auth middleware follows the same shape. Check the header before calling next and short circuit with an error response if the check fails. Notice it never calls next.serveHTTP in that case, so the chain stops there. Wiring it up is direct function composition. Logging middleware, auth middleware, mux. Reading it inside out tells you the request path. Auth runs first, then logging wraps the whole thing. No framework, no magic, just handlers wrapping handlers. Nesting function calls by hand gets unreadable past 2 or 3 middlewares. Deeply nested parentheses in the wrong order are an easy source of bugs. The fix is a small helper. Chain takes a variadic list of middlewares and returns a single middleware that applies them in the order you listed them, by folding from the last one backward. Chain, logging middleware, auth middleware, rate limit middleware. Mux reads top to bottom exactly as you'd expect. Logging wraps, auth wraps, rate limiting wraps your handler. Add a middleware, remove one, reorder them. It's a one-line change, and the same chain can be reused across every route in your application. This is the entire foundation that HTTP frameworks like Chi and Gorilla/Mux build on top of. Once you understand func HTTP, handler HTTP, handler and folding a slice of them, you understand how those frameworks work internally too. Sometimes you want to extend a running application without recompiling it. Load new functionality as a separate artifact. Go standard library has a plugin package for exactly this. Build a .so shared object with go build mode equals plugin. Then plugin. Open it at runtime and look up exported symbols by name. It works, but the constraints are real. Linux and macOS only, no Windows support. The plugin and the host binary must be built with the exact same Go version and largely the same dependency versions, or loading fails at runtime with an opaque error. And type safety is minimal. Lookup gives you an any that you type assert yourself. Get the signature wrong and you find out at runtime, not compile time. Because of these constraints, the native plugin package sees relatively little production use outside of a few specific tools. It's worth knowing it exists, but for most extensibility needs, there's a better behaved alternative. The pattern that actually gets used: define a plugin interface name, string and execute, config map, string interface, error, and a plugin registry that maps names to implementations. Anything satisfying the interface registers itself with register, and callers look plugins up by name with get. Concrete plugins are just ordinary Go types compiled directly into your binary. A logging plugin, a metrics plugin, whatever you need, each implementing name and execute. There's no dynamic loading at all. Extensibility comes from the interface boundary, not from the file system. This buys you everything the native plugin package can't. It works on every platform Go supports, the compiler checks every call at compile time, it's trivial to unit test each plugin in isolation, and deployment is just your regular binary, no .so files to version or ship alongside it. Unless you have a hard requirement to load code you don't control at runtime, this is the pattern to reach for. 2 more patterns show up constantly in Go codebases, and you've likely already used variants of each without naming them. The builder pattern chains method calls that each return the receiver, new query builder, table, users, select, ID, name, where active equals true, build, giving you a fluent, readable way to construct something with many optional parts. The strategy pattern swaps an algorithm at runtime by injecting different implementations of one interface. A payment processor holding a payment strategy that could be credit card strategy or PayPal strategy. Select it however you like. The observer pattern decouples a source of events from its reactions. A subject holds a slice of observers and calls notify on each when something happens, so the subject never needs to know who's listening or how many. And the factory pattern centralizes object construction behind a function, new database, Postgres, returns the right concrete type behind a shared interface, so callers never switch on type themselves. All 4 patterns from this section, builder, strategy, observer, factory, are just interfaces and functions, composed slightly differently depending on the problem shape. The idiomatic Go note that matters more than any single pattern. Go's culture favors simplicity over abstraction. Every pattern in this episode solves a real, specific problem, but applying one because it's available, not because you need it, produces code that's harder to read than the direct version would have been. Reach for dependency injection when you actually need to swap implementations or mock something in tests, not for every single field. Reach for middleware when you have cross-cutting concerns that genuinely apply across many handlers. Reach for the plugin pattern when you truly have pluggable, swappable units of behavior, not as a default way to organize a package. If a plain function and a concrete struct solve the problem, that's usually the better answer. Dependency injection. Define an interface, inject implementations through a constructor, enables testing with mocks, and keeps every dependency visible in the constructor signature. Middleware, func HTTP, handler, HTTP. Handler, composed by wrapping or with a chain helper for readable ordering. Plugins. The native plugin package works but is Linux/macOS only and version locked. Interface-based registries are the practical, cross-platform, compile time check default. Builder, strategy, observer, and factory round out the toolkit. Apply patterns because they solve a real problem, not because they're available. Next episode, the capstone project. We start building a concurrent web scraper from the ground up, using everything from goroutines to generics to the patterns in this episode. This course is based on the complete guide to Go programming, available on Apple Books and Amazon. Find it at pixelstech.net/book. See you in episode 26.